is why question 2014. It says in the circuit diagram above, E is a battery of negligible internal resistance. If its EMF is 9 volts, calculate the current in the circuit. So I'm going to do this one over here. So now to analyze, this is our DC energy source, and it has been said to be 9 volts. That means the EMF. That EMF means the voltage of the cell when it's not connected to an external load. You understand? That is, we are looking at the actual potential of the cell. Okay. So, and then they say we neglect the internal resistance. So we are not going to put that into our calculation. So we should calculate the current in the circuit. So what we want to find out is the amount of current being drawn from the battery or from the cell here. So let's use that to represent I. So according to Ohm's law, that voltage equals to what? Current times resistance. What we are going to do is we are going to analyze the equivalent resistance of the circuit here. So this R will represent what? Equivalent resistance. So if we find the equivalent resistance, we can then make I the subject of the formula to now be V divided by equivalent resistance. It will give us the current drawn from the cell. So let's analyze the equivalent resistance. Equivalent resistance will be equals to, now 5 ohms resistor and 20 ohm resistor are in parallel in the sense that they are being connected to the same terminal. You see, the front of this one connects here, the front of this one connects here, the back of this one connects here, and the back of, so that's a parallel connection. So that will be, so if you analyze them using your formula, it's going to turn to one equivalent resistance, which will now be in series with this 5 ohm resistance. So this parallel one, if you do it, that will be, since there are just two resistors in parallel, that will be 5 times 20 divided by 5 plus 20. And that will settle the parallel one. Then plus, which is in series with this one, plus what? 5. So this will be 5 times 20 divided by 25. I don't want to multiply it so that I can do some calculations easily. So 5 will cancel itself 1, cancel 25, 5. 5 here will cancel itself 1, cancel 24. So the whole thing remaining there will be 4 plus this 5 here, which equals to 9 ohms. So the equivalent resistance of this,
Our WhatsApp group to book
if you measure
online
from here
classes in real
to
time
here,
and also
from
get
this point
practice
to this point,
questions.
say point
The link is in
A
the
to
description.
B, if you
Thank
measure
you.
the resistance, it will give you what? 9 ohms. So now we've gotten the resistance, let's calculate our current. Therefore, our current I will be the voltage there divided by that equivalent resistance, which is 9 divided by 9 to give us what? 1 ampere. So the current, the total current drawn from the cell is 1 ampere. That's option B, 1.0 ampere. Thank you.